Hi everyone, welcome back. In the last video on email, we discussed about the architecture of email and what role does the user agent play in terms of email communication, isn't it? So in this video, what I'm going to do is I'm going to cover what is that particular standard in which that email has to be prepared and delivered. So just to give a small kind of recap, we know that the email architecture consists of two types of subsystems, one of which is the user agent, which actually allows the people or the human beings to send and read the email. And the second subsystem is the MTA, which is nothing but the message transfer agents, which actually move the messages from one point to the another point. That means a message, if it is to be delivered from the source to the destination, it is the job of the MTA. Now, this is the architecture that we discussed in the last video. So the messages sent by the user agent must be placed in a standard format to be handled by the message transfer agents. Now, let us see that this is our sender, which actually prepares a particular email. The user agent, which is situated here, what it does is it will allow the user to compose an email and then transmit it. So this email, once it reaches the message transfer agent, it should be formatted in a particular format, a standard format. That is what we are going to study in this particular video. We are going to study what is that format, how it is being handled, what are the different things that are actually added to your email so that it is enabled for transfer between source and the destination. In this, the first one that we are going to study is the RFC5322, also commonly known as the Internet Message Format or IMF. This IMF standardized by the RFC5322. I hope everyone knows what do you mean by RFC, request for comments. This is the once a standard or anything that has become a standard or once it is decided upon by the IETF, a RFC number is allocated to that, so that each and everyone who wants to use that technology or implement that technology has to adhere to this particular standard only. So this IMF, standardized by the RFC 5322 and maintained by IETF, specifies a syntax for the text messages that are sent between computer users within the framework of the electronic mail messages. In simple terms, what it does is it gives you a syntax about how email should be sent from source to destination. That's all. So it seems easy, but what it actually does. Just before we go there, let us just discuss about a brief history of from where did RFC 5322 evolve from. So RFC 5322, published in 2008, replaced the original standard RFC 822, which has been published in 1982. And this RFC 822 is the standard for the format of ARPA text messages. Do you remember? ARPA stands for Advanced Research Projects Agency, and the first network that is to be built is the ARPANET. So the RFC 822 was the format which has been defined for transmission of text messages during this ARPANET. What it does? So the email messages consist of a primitive envelope, some number of header fields, a blank line, and the message body. This is what usually an email message consists of. The original RFC, which has been published in 1982, was designed decades ago, a long time ago, and it did not clearly distinguish between the envelope fields from the header fields. There is no clear distinction between what is the header field and where is the body starts from. So the RFC 5322 defines the rules for the structure and content of email messages, including the headers, body, and the attachments, enabling transmission and receipt of emails from any device which follow this particular standard. So what it does is it has defined some syntax and rules saying that, see, if you want to send an email message, this is how it should look like. This is what the header should consist of. This is where the body starts. This is how you differentiate the header and the body, and even for attachments also. All those things are actually defined by RFC 5322. So it includes support for internationalized email addresses and also additional rules for handling spam and other types of unwanted messages. So all of these things are done by RFC 5322. As I said, the most common name that we call it is the IMF, which stands for Internet Message Format. Now, what it does. So these are some of the principal header fields that you commonly see when you open an email, isn't it? So the principal header fields related to message transport are listed below. The first field is the to, You know what do you mean by to whom you are going to send this email. CC is nothing but a carbon copy. It is the secondary recipient. BCC stands for blind carbon copy. And next comes the from part. So let me go in detail about each one of these header fields. The first one is the to field. It gives the DNS address of the primary recipient. Of course, you can add multiple recipients in the to also. That's what we usually do when you send an email, isn't it? If you want to send it to 3 or 4 people, you can simply copy and paste the addresses in the to part. Next comes the carbon copy. It gives the addresses of the any secondary recipients. From the perspective of an email system, there is no differentiation between this to field and CC field. The emails just get transmitted to both. Whereas a third one, which we call it as a blind carbon copy, it is exactly the same carbon copy field, except that this line is deleted from all the copies sent to the primary and secondary recipients. That means if I am sending an email to A, B, and put the name of C in BCC, both A and B does not know that this mail is actually being delivered to C also. That is the usage of blind carbon copy or BCC. The other two people, the primary and the secondary recipients, will not be able to see that this message or this email is being delivered to C. The next two fields, from and sender, tell who wrote and who sent the message respectively. Of course, these need not be the same, and sometimes it might be the same. So if I give the message to my assistant and ask them to send it, so the from will be the person who's created the message, and sender is the actual sender. So from will be my name and the sender will be my assistant's name, isn't it? So next one is the a line containing received, which is added by each message transfer agent along the way. This is usually used so that each and every message transfer agent will add its own identity, the timestamp, when this message is received. All those parameters are added into this particular path. Finally, from the information that we gained from this received header field, the return path field is added by the final message transfer agent and was intended to tell how to get back to the sender. So this return path, the name itself tells you that if you want to send a reply back to the sender, what is the path for this reply message to take? That is what it is being done. So these are the primary header fields. On top of these, there are many other fields that could be added also. And I'm just giving you a list of few of those additional fields that can be added under RFC5322. Most of them are self-explanatory. The first itself tells you the date, which is nothing but the date and time the message was sent. Reply to, it means sometimes that when I send a message and if you want to respond to it, I want that response to go to someone else. Maybe someone else is best equipped to answer that particular query. In that case, I can add this reply to field also. So if I send the message and I want my recipient to respond to, and that response to go to somebody else, that is what this reply to means. Then the next one is the message ID, which is nothing but it is an automatically generated number that is used to link messages together and to prevent duplicate delivery and all these things in reply to. So if you are sending an reply message, you can simply add the message ID of the message to which you are sending a reply from. That is the case in reply to. Next thing is references. Of course, you can add other message IDs for which you are creating this response or for which you are sending this new email. Next one is the keywords. The keywords are nothing but the user chosen keywords to maybe highlight the priority or give you a better information about the email. And finally, the subject. Subject is nothing but it's a short summary of the message for the one-line display. Most of the user agents might provide you with a one-line display which can be studied by the recipient and then decide whether to open this message or even simply discard the message. That is nothing but the subject part. All of these things are covered by the RFC5322 standard. Next, we come across the most important one and the one which we use every day, called as the MIME. This is a standard. RFC5322 does not support each and every attachment or anything else. That part is actually handled by MIME. So earlier, email has a simple structure and could only send messages in the NVT 7-bit ASCII format. NVT stands for Network Virtual Terminal 7-bit ASCII characters format. It cannot be used for languages other than English because some of the languages might not have the same exact alphabets like Japanese, Chinese, Hindi, etc. And some messages might have different pronunciations for these alphabets. And also there is no support for transmission of multimedia data like audio files, video files, images, or even binary files, executable files, Word documents, etc. The earlier email was only supposed to and designed for transmission of text messages only, and that too in English only. So for that purpose, a new protocol has been proposed which should actually work along with the old one. That is nothing but your MIME, Multipurpose Internet Mail Extensions, which is a supplementary protocol which is described in the RFCs 2045, 2047, 2045, 2046, 2047, 4288, 4289, and 2049, which allows the non-ASCII data to be sent through the email. So what it does is the MIME transforms the non-ASCII data at the sender side. So whatever data you want to send through the email, it might be ASCII or it might be non-ASCII. That data is actually converted by MIME into NVT ASCII data and delivers it to the client MTA to be sent through the internet. This is what it happens. So if you are the sender, what does the user agent do? It will take all the non-ASCII code and it forwards it to MIME. MIME converts this non-ASCII code into 7-bit NVT ASCII code, and then it forwards it to the email system for delivery. Once the email system delivers it towards the receiver side, at the receiver side, the same thing is done in reverse, so that the receiver will be able to receive the same non-ASCII code sent by the source. So the message at the receiving side is transformed back to the original data. This is how actually MIME works. Okay. Now, how does it do that? What does it do? For this purpose, for this conversion to take place, for this to support all these things, MIME actually defines 5 headers, which can be added to the original email header section to define the transformation parameters. So if you are sending an email and if you're having like these extensions or anything, MIME actually defined 5 different header fields. The first field is pretty simple, is the MIME version field, which tells the user agent or the MTA that it is now handling a MIME email. It is identifies the MIME version. Right now the version is 1.1. Next comes the content description. Let me go through this. So it tells the user agent that it's dealing with a MIME message and defines the version of the MIME used. The current version that is being used is 1.1. The next one is the content description. Of course, you can know that something tells description, which gives you more information, isn't it? This header defines whether the body is image, audio, or video. You can see that it is written content description. So it is nothing but the description of the content of the email. So it is a human readable string telling what the message consists of. It might be image, audio, or video. Then this is required so that the recipient can decide whether to decode the message and read the message. The third one is the content ID. We spoke about the message ID, isn't it? Which is an unique identifier for the message. This is pretty much similar to the message ID. This header uniquely identifies the whole message in a multiple message environment. It has the same format of the message ID header. The third one is the content ID, and the fourth one is the content transfer encoding. This is a very important one. So this content transfer encoding does actually tell you how your message is being wrapped up or encoded for transmission. What type of encoding scheme is being used? Of course, you can see this. This header defines the method used to encode the messages into zeros and ones for transport. MIME actually defines 5 different content transfer encodings. The first one is straightforward. It is the simplest scheme. Just the ASCII characters are there. They are simply transmitted as ASCII characters. The 7-bit NVT ASCII characters are used. Only the constraint is that any line should be less than 1000 characters only. More than 1000 characters, you have to select another line. The second one is 8-bit. So in this, still you adhere to this 1000 characters limit, but you will be able to send the 8-bit characters, non-ASCII characters with 8 bits representation. The third one is purely binary messages, true binary encoding. That means if you want to send an executable file where you cannot fix the length of it, isn't it? 100 characters or something like that. No, for those kind of arbitrary messages or this executable type of messages, binary coding is used. So the executable programs fall into this category. The last two ones are quite important. One of it is called as the base 64 encoding, and the next one is called as quoted printable. Let me explain to you how these two are used for doing the content transfer encoding. Let us first discuss about the base64. In this base64, if you have the non-ASCII data, you group it into a set of 24 bits. So this is a set of 24 bits. I'm showing you the example also. 24 bits are broken up into 6-bit units. So these set of 24 bits are now broken into 4 parts. Each part consisting of 6 bits. So 3 8s are 24, 4 6s are 24. 6 bits with each unit being sent as a legal ASCII character. Now each one of these 6 bits is now mapped to this value. We get this value. So this value is now converted into the ASCII character according to a table. The table is nothing but once you start with 0 for A, capital A, 1 for capital B, so long you have the 26 alphabets for the uppercase letters, 26 for the lowercase letters, then followed by the 10 digits, and we have a plus symbol and a slash symbol. So all these, we have a table for this base64 and converter, and according to the table, these values are now converted into characters and sent across the medium. At the receiver side, the same procedure is done, but in the reverse manner. But the problem here is every 6 bits become one ASCII character and are sent as 8 bits, resulting in an overhead of 25%. If your message contains very few of non-ASCII data and most of the message is ASCII data, using the base64 encoding is not efficient because it converts each and everything. Doesn't matter if it is ASCII or non-ASCII. It doesn't distinguish anything. So whatever the data is there, it groups them into 24 bits and then converts them into 6-bit chunks. And these 6-bit chunks are then mapped to a table and then sent as the ASCII character, which results in an overhead of extra 25%. This is not acceptable in some cases. So for messages that are almost entirely ASCII, but with a few non-ASCII characters, we go for the second encoding scheme, which we call it as quoted printable encoding. What is this? Quoted printable encoding is pretty much similar to what we studied earlier. If a character is not, the ASCII characters are sent exactly as they are. We don't touch anything with them. But if you see in this is a non-ASCII character 1001 1101. Now such non-ASCII characters are now sent as 3 characters. The first character is the equal to sign, followed by this next in hexadecimal. That means the first character is the equal sign. The next 2 characters are the hexadecimal representations of the byte. So 1001 is represented as 9. The second half of the byte 1101 is represented as D and then sent as the same using the ASCII data. So one non-ASCII character is now sent as 3 characters. You might ask, sir, how 1 becomes 3? Is it efficient? That's what I say, that this quoted printable encoding scheme is best utilized when the data is almost ASCII except from some bits and pieces of data. That's all. So these are all the content transfer encoding schemes that are defined by MIME, so that now you can send any kind of data through email. The last one is the content type. This header defines the type of the data used in the body of the message. The content type and the content subtype are separated by a slash. Now earlier, there are 7 types, content types that are defined by MIME. 1, 2, 3, 4, 5, 6, and 7. So you can see that there are 5, 6, 7. There are 7 types that are defined by MIME standard. And there are many subtypes that have been continuously added as every year goes by. Because the types of applications we are currently using, the types of formats that we are using right now, we get every day new formats. So in order to support all of them, we simply update the subtypes under this type section. You can see that for text types, you can see that there is a plain HTML, and recently it is the CSS and XML, or the extensible markup language, and CSS are also added under the text type. So if you are simply sending text message, then what will be there is text/plain. If you are sending a web page through email, text-HTML, like that. Next comes the image part. If you take image, The earlier it used to be JPEG and GIF, and after that now TIFF is also added. For audio, the first thing is only just a basic encoding, but right now you can send MPEG and also MP4, which allows the users to attach MP3 files also through your email. Same goes for video also. Every time in every year, slowly we keep adding more and more subtypes. Earlier it used to be only MPEG. Now we can send MP4. Now we can send QuickTime. All those video formats are also can be added to the email as attachments. This model type is the latest one which is added. Of course, it is not in more use right now, but there is another. This is another one which has been added to the MIME standard, where you can send 3D models also through email. Next comes the application thing. Application is a catch-all for all formats. That means if whatever file or whatever data which is not covered by any one of these other types, that comes under the application type. But please remember that whatever we are sending under this application type, it has to be opened by a particular application like your PDF, JavaScript, or zip file, octet stream to download and run executable files, all those kind of things. The next comes the message part. You can see that there are different subtypes that have been defined. Message HTTP, RFC5322. What it does is, it tells you that if this particular message is an encapsulated one inside another message, that is what it tells you. So if you can see here, the partial, it is a fragment of a bigger message, or the external body which is referring to another message or not. Like those kind of things are given under this message type. Next comes the multi-part type. Multi-part, which actually allows you to the message to contain more than one part. You can see there are many subtypes. There are 4 subtypes that have been defined here. The first one is a mixed subtype, which allows each and every part of the message to be different format. It need not be the same. Next comes the alternative subtype. This alternative subtype means the same message is used in different parts, but it can be expressed in 2 or more media. That means when I send a PDF document or some kind of document, you can open it in a PDF reader, you can open it in a browser, or you can use some other application, like those kind of things. For a parallel subtype, all the parts have to be played exactly at the same time simultaneously. If I open a particular video file, there is a video format in that, there is an audio format in that, but all of them should be played simultaneously. That comes under the multi-part. Okay, so these are all the different types and subtypes that are actually defined by the MIME standard. You can see that this is here. This is how the header actually looks like. We have the version, we have the type, subtype, we have the content transfer encoding, and what is the encoding type that is being used, what is the message ID, and then the description. Now, to understand MIME better, I have brought a simple example where we are actually trying to send a message from one point to the another point. You can see that we are sending a message from Alice to Bob. This is what it looks like. First, as usual, we have the MIME version, and we have the message ID, and we have the content type. You can see this is a multi-part alternative, and it says that there is a boundary which ends where the part ends. And this is the one-line summary, which is called as the subject. And after that, you can see the first part is content type, text HTML. So this is a link here, or maybe says a birthday card or something. Then once again, message external body. That means if you click on this, it goes to somewhere else and gets that and plays it for you. So for that, we can say that the content type is audio bar basic. So you might have something like maybe a song or something, or music, which once you click it, it should go to an external website and then play it for you. You can see the content transfer encoding also, which uses base 64. So like this, you can see this says the boundary, and this is the boundary done here. So in this way, all the MIME fields are actually can be seen in a particular email. The main purpose of going for MIME is to allow the email to have many attachments. The name itself tells you multi-purpose internet mail extensions. It is a vast development on the earlier emails where only text messages are allowed, and that too only in English. Now we are able to send any kind of message, and almost all types of attachments are allowed in an email. So with that, we'll stop here. And in the next video, I will discuss about the format or the message transfer part and how SMTP plays a role for transferring the messages from one point to another point. So till then, take care. Goodbye.